Hey, howdy, this is Mr. Potter. What we're going to be doing today is we're going to be talking about domain name servers, the DNS system that we've been mentioning, but how it's actually used in the real world. So I'm going to start by talking about the idea of root servers. And there are 13 root servers out there. And these root servers are actually named A to M. And there are actually 10 of them in the United States. There's one in UK, there is one in Japan, and there's one in Sweden. And so these 13 root servers are links to all of the top level domain servers that are out there. So there are 13 root servers, but in reality there are lots of different top level domain servers. Now, we've mentioned quite a few of these before. In a previous episode we talked about our generic top level domains, and these were the original ones that were designed in 1985. So this is your .com, your .org, your .net, your .gov, your .edu, and your .mil. Now, the reason I'm putting these three last is that these actually have quite a few restrictions on them. You can't get a .gov unless you're affiliated with the United States government. You can't get a .mil unless you're affiliated with the United States military, and you can't get a .edu unless you are a secondary higher level institution. So you have to be a college or a university to get that .edu. Wasn't always the case for these top level domains, but these have changed. And so these have actually moved over to what we've got here called the sponsored top level domains. So gov, edu, and military, they're all sponsored by different organizations. But some other ones we have, there's .aero, which is sponsored by the Airline Museum. There's .museum, and if you're a museum, then you can get one of these. There's also the one that we talked about, the .int, so when we're talking about international organizations. And this has really exploded. There have been thousands of these that have come up in the past couple of years. More being approved every year for every niche in society. If there is a group that wants to have a domain name, they can pretty much get it. And then we talked about these before. The CC stands for country code. So this is where we're using UK for the United Kingdom, FR for France, DE for Germany, CH for Switzerland, IT for Italy, but you can also see JP for Japan and KR for South Korea, CN for China. Every country in the world has a two-letter code assigned to it. And what you'll actually see is a lot of companies trying to treat these as if they were generic. So you might see people using .co, which is Colombia, but they're going to be using it as if it were a .com. There was a big sweep where people would do .ws for websites, even though this .ws stands for a country out there. That country, which would be some island that doesn't have a lot of tourism or commerce, but they can make a lot of money by selling these domain name services. So this is a way that some companies could actually make a lot of money. So these are the different top level services. Now what happens is you'll actually have the root servers, and the root server will have a connection to the .org name server. And the .org name server would be able to tell you, okay, how do I get to Wikipedia? Or how do I get to code.org? Or how do I get to any other site that ends in a .org? For example, I have a site, texasmath.org. And so anything in the .org hierarchy is going to have a link to tell you how to get to these different places. But they're not actually going to send you to the computer. They're actually going to send you to what we call a name server. In other words, they know who to send to. They don't actually know where my computer is, but they know who's in charge of my computer. So I do want to talk a little bit about name servers. So different companies use different name servers. Some companies use their own name server. Some companies use other companies for name servers. And so what I'm actually going to do is I'm going to show you my name server company. So this is afraid.org. This is a free DNS service that they provide. And they actually provide connections to my computer. This is my IP address. But what I've done with when I purchased my domain is I told them, hey, this company, afraid.org, is going to be handling my domain name services. So if anyone asks, send them here. And there are some flags that you've got here. For example, you'll see the flag A, and A stands for address. In other words, it's what links this domain, mistapotta.com, to this IP address. And whenever my internet service provider changes my IP address, I have to change this number on this website, which happens about once every 4 to 5 months. I also have another one. I've got this A, and this actually goes to drawl.mistapotta.com. This is actually the name of my computer that is physically on the internet, because our household has several computers. I've got my main computer that I do all of my work on. I've got my personal laptop. I've got my son's laptop, my wife's laptop. I've got the different devices that are connected to the internet, like game services and stuff like that. So the computer that's physically connected to the internet, the one that's actually serving all of my web pages and stuff, is Drawl. And it has the same IP address because this is the IP address that my internet service provider gives me. Now you'll see CNAME up here. This actually stands for canonical name. So in other words, people would type in www.mistapotta.com, and I'm saying, hey, if anyone types in this address, send them here. And then my computer will handle that by itself. And then I also have MX. MX stands for mail exchange. So if people send mail to mistapotta.com, it's going to go to this computer. And I've got a number here, 10. What I can do is I can actually have several mail servers and have them set up with a different number in front of them. So it's basically I'm telling the internet, try this mail server first, and if that doesn't work, try the second mail server. And if that doesn't work, try the third mail server, to ensure that email sent to that domain doesn't get bounced. Now, if I was running my own name server, then I would have another field called NS, and it would have the IP address to my domain name server. But because I'm using this website as my domain name server, I don't have that field here. And then if I was using the new IPv6, I would actually have AAAA. But my internet service provider has not provided me with an IPv6 number, so I don't have an IPv6 address to give. As soon as I do, I would have to put this field in here, and anyone who's in the IPv6 namespace would be able to type in my domain name, and it would find the connection to my computer. So I've got this, but I also have other domains. Let me pop over real quick. Let me erase what I've got here. Oh, come on, give me a bigger eraser than that. So if I pop over to the domains here, I can see other domains that I've got. This is my texasmath.org, and you can see under texasmath.org, I have a lot more services here. Some of the things that I do is I provide a forum, an online forum for people to type in stuff, or I have a place for people to get results. I have a wiki, in addition to having a www address. And so, but all of these are linking to the same computer, because all of these are on the same computer, they're just in different folders on that computer. Again, Drawl, of course, is the name of the server that I'm running. So I'm going to do one other thing here. Let me erase what I've got. But I'm going to jump to my physical computer. I'm going to show you the connection to the file service that I have down here. So here I am actually in my web server's file. So what I'm saying is that if anyone ever types in www.mistapotta.com, they need to go to this folder here, var www.mistapotta.com, and this is where I have the files for my website. And then this is my email address where people would send stuff to if they had any questions about where I am. And then if I have any errors or if I have a custom log, then it would add the error messages down here so I would be able to see what errors actually happen. And I actually have this for all of the websites that I run on my machine. So my texasmath.org, I have the forum here as well as other websites that I run. So it's really a three-step process going back to our document. You have the domain name server, which goes from the root server to the .org server or the .com server or whatever server you're using. And then this is going to go to that website's, so Wikipedia or Google's, whatever their name server is for their company. And then this is going to get their address, or this is going to get their mail exchange, or this is going to get the canonical name for that website. But each of these are going to be dealing with IP addresses. And this is how the internet works. So we've got our root server, which goes to the .org name server, which goes to the particular website's name server, which then gets the information to know which IP to go to. Now, our internet that we've got is very robust because there are fail-safes. Remember that there are 13 different ones of these, and there are actually several different .org servers. And when Wikipedia changes their IP addresses, they have to change in here. It actually takes maybe about 5 minutes for this change to be reflected. In the meantime, we're still getting the old IP addresses. And so that's why sometimes when your internet service provider or the other internet service provider changes the IP address, a website will be down just for a few minutes. It'll just be down for a few minutes until this change gets propagated so that all of the different .org servers or all the different .com servers, and there's a lot more of those, get all the changes and are able to send it to anyone who asks. Why do we have the domain server system, the domain name server system? It's because humans don't think in terms of numbers. If I give you a number, it's not going to be that easy to remember, especially since we're talking about a 3-digit number dot a 3-digit number dot a 3-digit number dot a 3-digit number. Or in the case of IPv6, we're talking about 4 digits dot 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 4 digits. And remember that these are hexadecimal. So that's a problem as well. So once again, this is Mr. Potter. Thank you for watching. Have a great day.